Valley rafters. This is a fairly complex project we're going to be looking at, so we're going to break it down into sections. We'll be exploring the various types of valley rafters. Then we'll be looking at valley jacks, valley cripple jacks, hip-to-valley jacks, and so forth. All right, let's get cracking. This is the roof plan for a valley rafter. It's the main ridge, and the slope off that main ridge is 6 foot 12 inches, as is the secondary ridge, 6'12", and the tertiary ridge. This is the roof framing plan. I've got this color-coded for you to help identify the different components. Common rafter is in black. Hip rafter is in green. There's 4 of those, 1 at each corner of the building. Valley rafters in cyan. There's 2 valley rafters. There's a shortened valley rafter, and there's a supporting valley rafter, which we'll talk about later. Hip jacks in red. These come off of the hip rafters. Valley jacks in blue, which come off of the valley rafters. We have a magenta valley-to-valley cripple jack and a yellow hip-to-valley cripple jack. There's 2 of those. Here's ridge beam A. This is a 20-foot span. Here's ridge beam B. We'll break down the links in more detail later. Ridge beam C. Let's take a closer look at ridge beam A. This is the section view. As we indicated earlier, it's a 20-foot span. Half of that is 10 foot, which is the total run. Total rise is 5 feet. And we're looking at ridge beam A now. We want to determine the height of this ridge. Here's a closer view. I'll take a detailed view now of ridge beam A, height above plate line. There's the plate line. As we mentioned, it's a total run of 10 feet, total rise of 5 feet. To the total rise, we need to add the height above plate line, which we're going to set at 7 inches. Then we're going to subtract the loss at top of 3/8 of an inch. The unit rise is determined by this formula. Rise divided by run, in this case 6 divided by 12 equals 0.5. You multiply that by the total run, and you come up with the unit rise of 5 feet. The height of the beam is the total rise of 5 feet, plus the height above plate line of 7 inches, minus the loss at top of 3/8 of an inch. And the formula is rise times half the ridge thickness divided by the run. Total height of beam is 5'6" and 5/8 of an inch. Ridge beam A, span of 20 feet. Let's see what's going on at the end of the ridge beam here. Here's the plan view. There's ridge beam A. There's the framing point. And what we need to do is we need to grow the ridge beam half the thickness of the common rafter. The common rafter is 1.5 inches. Half of the thickness would be 3/4 of an inch. There's 10 feet, which is half the span, plus 3/4 of an inch at the end, which we looked at. And the same thing on the other side, making a total beam length of 20 feet, 1 1/2 inch. There's the height that we spoke of before. And now we're just going to input this onto our rafter worksheet. There's ridge beam A. The height is 5'6" and 5/8. And as a reminder, that's the height from the plate line to the top of the ridge beam. And the length, as we mentioned, was 20 feet 1 1/2 inch. Back to the roof framing layout. We're going to lay out ridge beam A now using rafter marker 5A as the center line of your ridge. This is a close-up view of the end of the ridge beam A. You can see how the hip rafters and the common rafter intersect that. Ridge beam A, this is the layout. Now there's the reference point, 5A, which falls at the center of the beam. From there, we're going to start laying out our rafter layout marks along the ridge beam using the tongue of your rafter square, which is 1.5 inches wide. Just mark it off at 2 feet on center on either side of reference point 5A. We're going to take a look at a roof framing layout. This is the ridge beam A. This is common rafter 1A, special commons 1A, and then we have your regular commons 1A. Your hip rafters are indicated by the letter 2. Now we've already talked about common rafters and hip rafters, so this is a review. For your common rafter layout, one thing we're going to change is the framing square to 6/12, and we need to plug in different mathematical rafter links and mathematical overhang links than the previous tutorials. Same thing with the hip rafter layout. Change your framing square to 6/16.97, and we need to plug in our mathematical rafter links and our overhang links. Back to the roof framing plan. This common rafter has a 10-foot run, and the same thing with hip rafter, 10-foot total run. So for the key 1A, which is your common rafter, we just said that your total run is 10 feet. Total run for your hip rafter is also 10 feet. Now we need to multiply that by your unit lengths. For the common rafter, the unit length is 13.42, and for the hip rafter, your unit length is 18. Well, where do we get those from? Let's look down at your unit length formulas. Rise squared plus run square, and you take the square root of that. Run this through your calculator, and the result is 13.42. For your hip rafter, run this equation through your calculator, and the result is 18. You can always skip the math and just use our cheat sheet, Appendix F3. For your common rafter, where the unit run is 12, your 6/12 pitch gives you a unit length of 13.42. And for your hip or valley unit run of 16.97, your rise will give you a unit length of 18. So we just need to plug that into the equation. 10 times 13.42 returns a result of 11 feet 2 3/16 inch. For the overhang, 2 feet times 13.42 gives you a result of 2 feet 2 13/16. Then you run the math for your hip rafters, and the result is 15 feet for your rafter length and 3 feet for your overhang length. All right, back to your common rafter layout. You just plug that into your mathematical rafter length. And for the hip rafter, plug 15 and 3 feet into your mathematical rafter length and your mathematical overhang length. This is the plan view. And this is ridge beam A. "10 feet to the center of the beam." 10 feet to the center. And we're going to start putting the common rafters in place. This is the ridge beam being held up by some temporary posts. Since we've already established what the ridge beam height is, these should be relatively easy to fabricate on site. Here's ridge beam A. And these are the special common rafters and the regular common rafters. Hip rafters. Alright, so the first common rafter is going in place. And the common rafter at the other end. Your special common rafter. And your other special common rafter. When the moon hit your eye like a big pizza pie. Quick 3D view. Now the hip rafters. Geez, these guys are slow. Closer inspection of the intersect point. Mirror that to the other side. All right, this is our 3D view. Close inspection of the intersections. And this concludes the portion for the ridge beam A. Next, we're going to take a look at ridge beam B, and we'll begin to start using some valley rafters.